We're on problem 201, which I had continued in the last video, but frankly, I had bad reading comprehension. I had read the first statement right, and I went down a kind of incorrect path. So let me read it correctly. If the sum of n consecutive integers is 0, which of the following must be true? So I have n numbers in the row, and their sum has to be 0. So first of all, that tells us that some of them have to be positive and some of them have to be negative. And they're consecutive, right? So if we put this as 0, I mean, let's think about how we can even construct this, how this could ever happen. N consecutive numbers, the sum being 0. Well, if we have, I mean, it really, in order to do that, and they're consecutive, which is a trick. If A is one of the numbers, then really negative A has to be one of the numbers as well. And why is that? You might say, oh, well, why can't I have some other set of negative numbers that offset A? Well, the key here is that we're dealing with consecutive numbers, because those other negative numbers are going to have to offset all of the other positive numbers in between. I don't know, maybe I should do this with more abstract. So let's say that n is equal to 1, right? N is the sum of n consecutive integers is 0. So first of all, can n equal 1? Well, sure, only if that one integer is 0. Right? Now, what if n is equal to 2? Can n equal 2? Well, let's think about it. We have to add one integer to this, and they're integers, right? So if we add one integer, if we add any positive integer here, a, then the sum is going to be 0 plus a. I mean, if you're going to cross the negative boundary, if you're going to cross 0, 0 has to be one of your integers, right? So that's always going to be counted. So in order to get to negative a, you need to have at least 3 integers, right? So if I said that n is equal to 3, sure, you could do 1, 0, and minus 1. Now, if n is equal to 4, can I just add one number on either? Can I add either a 2 or a negative 2? No, that'll change the sum again. So I have to add a 2 and a minus 2. So I think you can see here that there's a pattern, because 0 is always going to be one of the integers, and it's symmetric on the right and the left-hand side. We're always going to have an odd number of integers we're summing up. So we know that n is odd. N is odd. And let's see what it is. So we know statement 1. They say statement 1, n even. That's not true. We actually can't construct it with n is even. Statement 2 says n is odd, which we've just shown. And then statement 3 is the average of the n integers is 0. Well, sure. I mean, what's the average? It's the sum. It's the sum of the integers divided by n, right? Well, they're telling us that the sum of the integers is 0. So 0 divided by anything, as long as we don't have 0 integers, is 0. So 2 and 3 are both correct. So the choice is E. Next question. 202. 202. Excuse me. In the formula, v is equal to 1 over 2r cubed. If r is halved, then v is multiplied by what? The easiest thing I always find to do in this is take numbers. So let's say if r is 2, what happens? And then let's halve it when r equals 1 and see what happens to v. I mean, we could do it analytically, but this is frankly the easiest way to do it. So you could say when r is equal to 2, v is equal to 1 over 2 times 2 is 4 to the third power 64. And then when r is 1, you get 1 over, 2 times 1 is 2 to the third power. So you get 1/8. So what happened to v? We essentially multiplied it by 8, right? So that is choice B. To go from 1/64 to 1/8, you have to multiply by 8. You could view 1/8 as the same thing as 8/64, if that clarifies it at all. I always find it easier to deal with actual physical numbers where they say, oh, if you change this variable by a factor of 5, what happens to that variable? So easy to just, well, anyway. It could get very confusing if you actually try to do an R1 and an R2, and R1 is 2 times R2 and all of that. Next question. 203. A certain bakery has 6 employees. It pays annual salaries of $14,000 to each of 2 employees. So 2 make 14K. 16,000 to one employee, so one employee makes 16K. And 17,000 to each of the remaining 3 employees. Fair enough. The average annual salary of these employees is closest to which of the following? So we have to take the sum of all of their salaries and divide by 6. So it'll be 2 times 14 plus 1 times 16, which is 16, plus 3 times 17. 3 times 17. And we divide it by 6. 2 times 14 is 28, plus 16, plus 51. All of that over 6. And let's see, what is that equal to? 28, 16, 51. 8 plus 6 is 14. 14 plus 1 is 15. 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 5 is 9. Right? And this was 8 plus 6. Right? So it's 95 divided by 6. Sorry, 95 divided by 6. I think my brain was computing ahead of me because 96 divided by 6. So 96 divided by 6 is equal to 16, right? So this number is just going to be just under 16. It's 15 and 5/6. So they want to get an approximate as close as. Oh, actually, no, they have a lot of numbers that are really close. So let me make sure that I get it right. So 6 goes into 95. If they didn't have numbers that weren't close, I wouldn't do this. 6 goes into 90. 6 goes into 9, 6. 35 goes 5 times. 5 times 6 is 30. Remainder of 5. Actually, let's keep going because we want a decimal, right? Because we're doing it in thousands. So bring down a 0. 6 goes into 50. 8 times 6 is 48. Remember, we were dealing in thousands when I said, 16. That was with thousand. So, now we're at 15.8 thousand. So 8 times 48, 20. 6 goes into 23 times. Okay, I think that's close enough to what we need, right? So it's going to be roughly $15,800. Or 15.8 thousands. And that is choice C. At first I said, oh, maybe we can approximate, and they had 16,000 there, but then I saw the 15.8. So I was, oh, well, we should do a little bit more math. We don't want to get too careless. Next problem. 204. 204. If x is equal to the sum of the even integers from 40 to 60 inclusive. So 40, so x is equal to the sum of even integers from 40 to 60. This is my ad hoc notation. And y is the number of even integers. And y is the number of even integers. See, if x is equal to the sum of the even integers from 40 to 60, inclusive, so it includes 40 and 60. From 40 to 60, it includes both of them. And y is the number of even integers from 40 to 60 inclusive. What is the value of x plus y? Okay, so the number, y is an easy thing. How many integers are there between 40 and 60 if you include both of them? So, and this is always a tricky thing to think about. But if you think about it, if I said the numbers 1, 2, and 3, how many integers are there here? Well, clearly you can count them, 1, 2, and 3. But if you wanted a quick way of saying it, you could say, okay, 3 minus, if I just took the end point minus the starting point, I would get how many I would get these integers, right? So then I'd want to add 1. So if I wanted to know how many integers are there between 60 and 40, I would say 60 minus 40. And that'll give me 41, 42, 43, 44, all the way to 59 and 60. And then I have to add 1 because we're including 40 as well. So y is equal to 21. Y is equal to 21. Now let's think about, is there an easy way to add up all of the integers between 40 and all of the even, y is the number of even integers from 40 to 60. So that's not right. So the even integers, frankly, it might just be easier to, let's just write them out. 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, and 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 integers. So that's y. And we need to take the sum of all of these, right? So there's a couple of ways we could think about it. You could view this as 40 plus 0, 40 plus 2, 40 plus 3, and so forth, all the way to 40 plus 8. And so if you wanted to add up at least up to this point, there's a pretty straightforward way of doing it. You could just say, well, that's four. There's 1, 2, 3, 4, 5 of them, so it's equal to 40 times 5, right? That adds up all the 40s, plus 2 plus 4 plus 6 plus 8. So 2 plus 4 is 6, plus 6 is 12, plus 8 is 20. So plus 20. So that's 40 times 5 is what? 200 plus 20 is equal to 220. And use the same logic here. This is 50 plus 0, 50 plus 2, all the way to 50 plus 10. And how many are there? There's 1, 2, 3, 4, 5, 6. So it's equal to 6 times 50. 6 times 50 plus 2 plus 4 is 6, plus 6 is 12, plus 8 is 20, which we actually already knew. We already calculated there. It's 20. Because these don't contribute to the. Oh, no, plus 10. Sorry, plus 10. Don't want to get careless. Plus 10, right? Because there's 6 of these, and it's plus 0, plus 2, plus 4, plus 6, plus 8, plus 10. So it's 20 plus 10, so it's 30, right? 2 plus 4 plus 6 plus 8 plus 10 is 30. So 6 times 5 is 300, plus 30 is equal to 330. So 330 plus 220. And these numbers have a strange pattern. Well, there is a formula if you want to add the first n numbers, but now they changed it a little bit by talking about even numbers, so I wanted to do it manually. So you go 0, 5, 5. So 550 is the sum, and then we know that y, this is x. X is equal to 550, and y is equal to 11. We figured that out before. So x plus y is equal to 550 plus 11, which is equal to 561, which is, thank goodness, actually one of the choices. And that's choice D. See you in the next video.